Hello. Sorry, I'm just getting over a bit of a respiratory thing, so my voice is a little bad. But in this video, I'm going to teach you how to use the calculator to do hypothesis testing. Since I'm mostly just teaching you how to calculator, I'm going to kind of just run through this. There's this example with Jeffrey, an 8-year-old swimmer, and his intense sports stat Frank, right? And just to show you, right, how to enter in the claims, right? So notice in this case, this is one of the rare cases where the where you are testing the mean and you know the standard deviation. So in such cases, right, you do a hypothesis test of the mean. So you go over to, so I hit the stat button here, go over to tests, and since this is the rare case where I know the mean, that means this is a z-test. You want to change your, so there's two ways you can do tests. You can put in raw data or the summary statistics of that data, right? So in this case, it is stats, right? So anytime you know, and then it's just information. So first, you not is, you're making, is like saying, what is the null hypothesis, right? So this is a null hypothesis. In this case, the null hypothesis is the mean is equal to 16.43, so I put in the 16.43. Since this is a z-test, we know the population standard deviation, so I want to enter that in here, which in this case is 0.8. You want to enter in the sample mean, which in this case is 16. You want to enter an n, which is the sample size, which is 15. And then you want to tell it whether it's a two-tailed, left-tailed, or right-tailed test based on the type of alternative hypothesis. So in this case, we are hypothesizing that a number is greater than 16.3. Or sorry, we're hypothesizing that our mu is less than 16.43. So it's the second one, and then you hit calculate, and boom, it gives you your test statistic, and it also gives you your probability, right, value. So, but you have to interpret this yourself, right? It doesn't do that for you. So here you see, okay, right, we have a alpha of 0.5, or in this case our p is less than alpha, so that means we reject the null hypothesis, right? And then you have to interpret that and whatnot. Okay, so that's how you do it with the t-test, right? Now you might also, like in this case, instead of telling you, hey, you know, Jeffrey swims were like this, it had this mean, the standard deviation. Here, we just have the raw data. So in that case, right, you want to first enter in your data. You want to go edit and put your data in a list. So here we do that. 65, 65, 70, 67, 66, 63, 68, 72, 71. Now this is just entering your data in a list, which again, remember, you just hit the stat menu and then just hit edit to put your stuff in a list. Okay, so then again, you do stat, tests. This case, since the standard, which is the most case, you don't know the standard deviation of the population. You know it of the sample, right? Because you have all the data for the sample. So then you want to do a t-test. And again, this time you just click data. And right here where it says L list, you just want to say what list it is. Usually that would be L1. Just don't mess with the frequency. Keep that at 1. I don't even want to really think about what's going on there. Now the claim is that it involves, right, the null hypothesis is the mean is equal to 65, right? And in this case, it is right-tailed, so let's change that. It's greater than, right? And notice we didn't have to enter anything about the sample because we just kind of gave it the sample right there in list 1. Calculate. So there you go. It gives you, again, the test statistic, right? What happened there? No, I got the wrong numbers. I must have entered in one of the values wrong, but nonetheless, let's see. 65, 65, 70, 67. Oh yeah, I'm missing a 63. So that explained why I have different values than they do, but nonetheless, that is how you enter in the stuff. So just remember, right, this is how you find the stuff, right? You go to stat, and then you go over to tests. Z-test if you know the population standard deviation for a mean. T-test if you do not know the population standard deviation. You'll be doing the t-test much more common. Now if you want to go back to what we did in A2, it also can do for proportion tests, but it's a little weird. So this was the one with the drug use, how many failures, etc. So in that case, you want to go over to tests, and then you want to be careful to make sure you use the right one. You want to use 5, 1 proportion z-test, right? You want to put in what is the null hypothesis, right? Which in this case is p is equal to 5.8%. You have to enter it in as a decimal. It will not work if you enter it in as a percentage, right? And then you just need to say how many, right? Instead of asking you for P naught, it calculates P naught by dividing by X by N, right? So in this case, there are 58 failures. And there are 1520 applicants. If you were just told P naught, right, that would be the proportion. So if you have P naught to get X, you just multiply P naught by N, right? But most of the time, you're just directly given the number of failures, the number of whatever. And then again, you have to say what it is. In this case, it's less than. All right, and it also gave us the percentage here, which we calculated. So it says P, it gives you P hat as well. Notice this P right here, this is a very small number. This is not 4 something. This E, -4. That means .67 times 10 to the -4th, right? Which means like this is a bunch, which means that it's 3 zeros and then this, right? So that means a very small. Anytime you see E, right, in your thing and a negative number, that means you have a very small probability. So basically, in conclusion, anything that has an E with a negative number after that, just treat that as approximately 0. Okay, and then you can see it gave us the same test statistics here. But again, you have to interpret it, right? So that's how you have to do that. And yeah, right? It won't tell you the conclusion, but it will give you the probability and the test statistic, right? So that will allow you to make a conclusion whether you're doing the critical value method or the probability, because in either case, you have the comparison. And yeah, so that's about it. And good luck, guys.